to all of you participants at various centers, and it's my pleasure to introduce Dr. Rakesh from Computer Science Department. He has a long experience of more than 10 years in teaching and research. Before joining this institution, he was assistant professor in Maulana University, Ambala, and at present he is contributing in this institution in various activities of the institution, that is education and training, research and development, instructional material development, and even now his own course is going on, but we have requested him to interact with you for an hour for discussing emerging areas in engineering in the field of computer science. So Dr. Rakesh, please.
Thank you, ma'am. Good afternoon, participants. Thank you, ma'am, for giving me an opportunity to have an interaction with the participants present at this center at NITTTR Chandigarh and various remote centers. I think 7 centers are connected with us for this course on research methodology. So I hope you have already, ma'am has already covered, I think according to timetable, ma'am has already covered the basics of research methodology. I will just discuss 2-3 slides regarding this. Then I will move forward towards the what are the various emerging areas in the field of computer science and how we can proceed our research in this area. So before that, I would like to discuss what basically a research is. According to various dictionaries, it has different definition, and ma'am has already discussed about this, I think. So it says it should be about some problem that encourages us and interest for the others. And this encouragement or enthusiasm should be such that we ourselves work toward this research. That has something happened in the past and we are going to contribute over it, and that will be meaningful or beneficial for the society or for the upcoming users, those who are going to work in this area in the near or upcoming future. And it is often generated from the thought that what if we have got now from the past is not quite good enough and we want to do it better. Then and only that actual research will go ahead. If we work only on the previous thing that has happened and we feel that it is sufficient for us, we don't want to contribute further, it is okay, then there is no significance of doing the research in this. And it consists of work such leads to the meaningful contribution, generates in some way a better solution to the existing problem. Although a lot of solutions have already been proposed in the literature by the various authors or scientists for the existing problems, but there is the scope of improvement. Always there is a scope of improvement in these problems. So we can further improve it by providing either the complete new solution or just increasing the performance of the previous solutions that has already been proposed by the others. So according to the Merriam-Webster dictionary, or you can say the definition, it says research is the careful or diligent search. Research itself says re and search. Again doing the same thing, that is the searching again and again, that contributes to the research. And it is basically a studious inquiry or examination, especially investigation. And this investigation is done with the help of experimentation that is aimed at the discovery and interpretation of facts, revisions of accepted theories or laws in the light of new facts. We are not denying the existing theories that are existing in the past, but we are just going to improve it if possible, and practical applications such as new or revised theories can also be proposed in this. And this collecting information about a particular subject also contributes to the research. There are some other definitions also which says it is a combination of investigation of past work and effort in the present that will help others in the future. As I said earlier, this research is what it encourages us to do something that has already been happened in the past, and we are going to contribute over it that will be beneficial for the others. And these are some sets of opposites also for the research. It is fun and frustration, we can also say, because when we start doing the research, sometimes we also come in stage where we find these kinds of opposites also. It is small steps and large insights, because as we move step by step inside it, it is more and more deep inside. So, but as soon as we started doing the research from the core of our heart or from the full efforts we provide to it, then we start enjoying the research. And building on others' work and contributing your own work, these are just the opposites. Wasting of holidays and weekends. Sometimes students also say like this. Finding or developing something new that changes the world is basically the research, and our aim should be such that we are going to propose some solutions that will be beneficial for the others in the coming time. This research may be of two types. It may be quantitative or it may be qualitative. And this both these approaches are applicable in computer science also. In other fields also these approaches are applicable. In quantitative research, we use statistical, formulaic or numerical analysis to generate the results. And the most important thing in this is we propose the solution, and this solution is this much percent better than the previous one. We basically give the figures in terms of this percentage or the values, how much we quantify the results, how much quantity it is better than the previous one. And its main approach is analysis, causal determination, prediction, generalization of findings, etc. And on the other hand, qualitative research says we are not going to quantify the things, rather we are going to propose a complete new solution, and there is no comparison between the previous one and the new one. We cannot quantify in terms of numbers. So in case of qualitative, it is not quantitative, and we use non-numeric techniques. And main approach is here basically the discovery or illumination of the new facts, new theories, exploration to the similar circumstances. And results here, this is a new way of solving the problem. We cannot quantify it with respect to the earlier ones. And this is the scope of research. It varies from different levels. Research can be done at the graduate level, it can be done at the postgraduate level, it can be done at doctorate level or postdoctorate level. Research is also being done by the faculty or other staff in the universities or colleges, and research is also done by the scientists working in the like R&D labs or the industries. So different levels of research is being done at different levels, and different contributors are contributing in this field. Whether in this case of where PhD students are as well, basically when we talk about the research in our country, we are most focused on the PhD research, because here people are most of the people are who are actually doing the research, and they are from these PhD students who are the most bothered about this. And contribution expected in case of PhD students is at the world level. We expect that our students who are doing their research or they are doing their PhD, their work should be expected at the world level, and they will be able to publish or they will be able to present their results or their contribution at the world level, so that others can also feel that this is really a significant one that has been done by the researchers. And for this, the work should be at the level of world level. We should do the background investigation on all past work. We should do the thorough research of the background, what has done in the past, and make meaningful addition to the world knowledge. Whereas in case of undergraduate students, contribution can be at the local level also. It may go up to the world level, from local to national and national to world level, but to some extent in our universities or colleges, we are limited only to the local or national level when it is undergraduate students. We expect it is okay from our side. So background investigation is done here at the university, but it can go up to the world level, and meaningful addition to the university, so that the university people who are using some kind of software, suppose we are going to develop, that will be going to helpful for the university or at the local level. And there are some definition which says that this is not the research. Some people are having some kind of misnominous, they find that this is also a research. Like if we are going to playing with the technology, suppose we are able to learn suppose new language, and we are good enough so that we are able to write the program with the help of this new language, then it is not going to contribute as the research. Like suppose you are the participant of this course, suppose in this course we are going to teach you some new language like R programming and some other SPSS tool. If you are comfortable enough to play with these technology, it doesn't mean that it is a research. It is basically a part of research in which you have learned a tool, and that tool you are going to apply when you are going to implement your actual theories that you have proposed. Writing the book report is also not the research, it is also a part of it. Programming project, as our undergraduate students, most of them just automate the existing system with applying the existing theories. It is only this automation of the things. It is not the project. Sorry, it is not the research, it is just the project. Doing what you want to ask some? So doing what others have already done is not the research. If you are going to contribute over it that has already been done by the others, then and only then it contributes as the research. All these are just the part of the research that as research as it is written here. Each of these can be done as the part of the research. Now, as I said, who does the research? Graduate students, researchers at universities, faculty and staff at universities, and researchers at the various industries or R&D lab. So as we can see here, obviously the work that has been done by the master degree student is comparatively of lower standard as compared to the PhD degree student. After that, if we move forward to the postdoctoral level or faculty member, the quality of research is comparatively better. And further, if we move towards the researchers who are actually performing this implementation of these results in the industries or R&D labs, the quality of research is further more better. But as we find in the previous few years, the research that is available in the form of publications, that is only from the researchers at the universities, whether it is student or faculty. Those who are actually working in the R&D labs or in the scientists working in these industries, they basically try to hide their work so that the other competitors cannot launch the product before their product is actually launched into the market. So that is why we don't have much information available regarding these researchers going on these R&D labs and these industries. So in our country, generally research is more focused onto the individual, but in other parts of the world, research is done in both, whether in the as an individual level as well as the team level. Rather, in the other part of the world, team contribution is more as compared to the individual. There are the team members, and each team member is having a different role. Like one is suppose going to propose the theory, and another one is suppose helping in the implementation. Other person is writing the report. Other one is going to proofreading, and every team member is having the role. When in our country, most of the research is individual centric, and the one person is completely doing the all work. Always team always the process easier, because suppose if there is any deviation from the main point, then there are suppose group member, they can bring the group back onto the right track. But suppose if there is only one individual person and the research is deviated from the actual right direction, then it is very difficult for oneself to identify his own or her errors. So it is always better to have a team. Feedback from the team members also improves the quality of the research. That is also a key point of team. Each member can work to its own strength, because each member is having some strength, and then strength can be applied here, because an individual cannot be best in all fields. He cannot implement, cannot be good in suppose writing the report, he cannot be good in proposing the new theories, he cannot be able to do all these things at once. Always it is better to do the research in a group. This is the research process or the methodology that is being followed by the various researchers while doing the research. So whenever we are going to identify or suppose start our research, we should first know in which area we are going to work and what is the application of this, because without any real world application of your research, it is of no use. So first you should identify what is the application. Like suppose in computer science, if you are going to do your research in the area of suppose wireless communication, or suppose mobile computing, or suppose big data analysis, you should first know what are the real world applications of this. Then and only then the interest will generate. And after that, after finding these use cases or application, then you will get the motivation, how this research is important for this, and what has existing the work that has been proposed by some of the researchers. After that, you should find out what was the initial idea proposed by someone else who has proposed this one. Where this research basically started in this area. When was the first, suppose if we are talking about the big data, when was this first coined, and who coined this, and after that what has been done, that will be covered under the part of background investigation. After first this term was coined, what has been done by the various scientists or researchers at different level, whether it is a graduate level or it is at the researchers or scientists working in the R&Ds or industries. After that you refine your idea, then core work start, where you investigate and develop the things. You investigate key what has been done by the others, is it sufficient or something can be added to it, is there anything that is lagging behind, we can improve on it. So that comes under the category of problem formulation. You are trying to formulate your problem. After that you propose your solution, that may be in the form of either prototype or you propose some new laws. Then you write the report. Parallelly this process will go on, documentation part. Then you evaluate, and then finally the results will come. Then you identify what you can do in the future, and this whole thing you can publish in the various journals or conferences, or you can file for the patents. To do a good quality research, we should know from where we should start doing it. Like as I said earlier, I should know the application, I should know the motivation, what is the motivation there, from where I will get this information. One solution is you just write the word onto the Google, but Google is basically a search engine. Through that you will get just the basic information or fundamental information for the basic learning, that is okay. But for do the higher level of research, you should know which journal is good, from where you will get the good information, and which journal is not good enough to refer. Like suppose if we are going to attend one STC, so I should know where this course is going to be conducted, from where the experts are going to become. Suppose a course is going to be conducted at IIT, and suppose another course is going to be conducted suppose on remote location. Obviously the quality of course that is going to be conducted at IIT is somewhat better. So likewise there are a lot of journals or publishers available, so they publish a lot of material, but we should know which one is good and which one is not to be referred. This is just my suggestion and my view, and you can follow whatever you want exactly. So but there are two types of publishers available here. One is the open access, and the one is the paid. Open access journals, they are free for the viewers and paid for the authors. So suppose I am going to publish one article in the suppose journal, in this kind of journal, so they will charge the money from the author, and viewers, those who are going to read this article, it is free of cost available onto the internet, or maybe in the form of hard copy. And there are other types of journals also available, that is free for the authors and paid for the viewers. Suppose whenever I am going to publish any article on it, so they will not charge any money from me. But whenever I am going to view some articles, they will ask for the money, or they will request for the membership. So generally these journals, those are free for the authors and paid for the viewers. They are of good quality. We should refer such kind of journals, not for the first category. Although in the first category it is available free of cost, so we easily, when you Google the thing, it is available. So in most of these colleges, the second category is not available. The journals, those are free for the authors and paid for the viewers. And whenever we are going to refer, or when we are going to publish our work, there are two categories: journal, conference, and third one is the patents. Generally patent is it takes a lot of time, and it varies from country to country. Suppose I want to file one patent with Indian government, so it will be filed over there. Generally most of our researchers are limited to the conferences and journals. So in case of journals, when we want to publish, we have doubt we should go in which we should publish our paper in which place. So in journals, it has multiple round of review. Length of paper generally required by the journals is comparatively longer. Generally there is no deadlines for the journals. It is open all over the year. You can send your paper to these journals anytime. Journals may or may not have impact factors. Good journals have impact factors. Journals may be as free or paid. As I said in the previous slide, the journals, those who are free for the authors are good, and paid for the viewers, these are good. And no need for the presentation here in case of journals. But in case of conferences, there is a single round of review. As I submit my paper, it will go to the reviewers. They will either accept it or reject it, or it is accepted with some revisions. But in case of journal, there may be multiple round of review. So the quality of paper is comparatively better in journal. Length of paper is short in case of conferences, but in journal, the length of paper is quite long. So we get the complete information of the work that has been done by the researchers, like from where this work was started, how they have proposed their their new theory, how they have implemented it, what are the results, which simulator or suppose real world environment they have taken, what parameters they have taken. So more details are given in the journal. But in case of conferences, as the size of the paper is limited to generally 6 to 8 pages, so all this information cannot be given by the authors in this. And these conferences have deadlines, and these are paid. Always they charge some money, and presentation is also required in case of conferences. This is the good part of conferences, that they require the presentation. So when you go to attend these conferences, you are more able to learn or listen to the other authors or speakers, those are working on these areas of new areas of the research. You can just able to learn it, because whenever you are going to listen to these authors, it is in this you gain more as compared to the journals, where you are just going to read the articles available onto the internet or in the form of hard copy. You can ask the questions also to the authors or speakers during the presentation. These are some of the reputed publishers. uh, as I said earlier, there are two types of publishers available, free and paid. These are some publishers who are reputed one. You can note down if you want. I think some of you may know about this, like IEEE. It is well known amongst the students and researchers. IEEE is the one. Springer, Elsevier, InterScience, Wiley, IGI Global, Taylor and Francis. There are some other publishers also. These publishers are generally in the field of computer science that I know. There may be some others also. But for the person who are going to just initiate their research in this area, they can go through these publishers. They publishes lot of journals for each area, like if you are going for wireless communication, or for big data, or for data mining, for image processing, signal processing, they publishes very large number of journals. So now moving towards the emerging areas of various research that are possible in the area, in the field of computer science and engineering. Now, these are the various areas on which you can contribute, like the ad hoc networks. We have wireless sensor networks. We have mobile ad hoc networks. In case of ad hoc networks, you can work upon ubiquitous computing. You can work upon artificial intelligence. You can work upon big data. You can work image processing, computer vision, human computer interaction, which is nowadays one of the major area of research. And it is also somewhat coming up field in which researchers are doing the multidisciplinary research, like people from computer science and electrical. They are both doing the research by doing the collaborative research, like some of them are building the arms of, suppose if there is some person who are physically handicapped, they are just doing this artificial touching the artificial arm to the human and providing the senses from the brain so that it will work according to the real arm that is attached to the persons. And such kind of research is going on nowadays. You can also work on machine learning, natural language processing, software testing, robotics, security and privacy, systems and networking, IoT. There are some other areas of research are also available. We will discuss few of them here. Like the first one, in case of ad hoc networks. Ad hoc networks is a very vast field. It has some other subcategories also. Like I said, the mobile ad hoc network. We have regular ad hoc networks. We have some mesh networks also. These are some part of it. So you can work upon any one of it because they have some similar properties. But when we go deep inside this ad hoc networks, we can work on different areas. The first challenge in case of ad hoc network is the routing. How we can route the packet from one location to another location, because these mobile devices, they have limited battery power, they have limited radio communication range. They can communicate up to suppose 500 meters or less than that. 500 meters is even too much. It can work on 200 to 300 meters. So if you want to communicate from after that, there should be a link between these nodes, because these nodes are also mobile in case of mobile ad hoc network. Suppose a node want to send a packet to C, and A and C are not in direct range of each other. So A can send the packet to B and B can further forward it to C. So for this, a routing is involved, which is a key role in case of ad hoc networks. So for this, you can propose new algorithms or just study the previous existing algorithms, how they are working upon, and can you improve some of the parameters in it. Like when we talk about ad hoc networks, there are certain parameters like the delay, after how much time one packet is delivered from one location to another location. Is it possible for us to reduce the delay, or can we increase the throughput of the network, or can we increase the security of the network by applying some algorithm without further increasing the delay in the network? So if you are going to add some code for the security, then definitely it is complexity of your algorithm will go up. So we do not want to increase the complexity. Such challenges are available in case of ad hoc networks. Likewise, the channel contention is also a major problem in case of ad hoc networks, because there is a common medium that is shared by all the nodes in wireless in this ad hoc network. And suppose I want to send a packet through using this medium, all the nodes are basically sharing this common channel. So they are contending for the common channel, and each one of them want to send their message. So it required the channel contention. It is also a big challenge how a common device is shared among these nodes who are part of this ad hoc networks. Clustering is also possible in case of ad hoc networks, like whenever there are some group of nodes, those are part of a team, they want to work together, we can form a cluster head out of this. And after doing this clustering, the challenges are like how you can reselect cluster head, because if you choose any node as the cluster, the battery consumption of that node will be very high, because all the packets from that cluster will be passing through that cluster head. So it is required that you just rotate the cluster head after some time. The selection of cluster head and the choosing of cluster head is also a major challenge. You can propose a new algorithm or new way of finding this cluster head. Energy efficiency is also a challenge, because all these nodes are on the passive power supply. There is no active power supply provided to it. So as soon as this battery is dried up, this node will not be the part of the network. Then quality of service, that is the QoS. This is another sub area on which we can work upon. This quality of service represents the qualitative and quantitative representation of the user's requirement. As I said, the throughput, jitter, delay variance. These are all the parameters that represents the quality of network. So can we improve this by applying some techniques or new theories, so that the quality of service of the network can be improved, so that user will get the better bandwidth, there will be no delay while downloading the information from the internet, live streaming we are doing. Then there will be a congestion also in the network, because as soon as more and more nodes are the part of the network, then there will be a congestion. So we want to have some congestion control algorithm, so that we will be able to detect, is there really a congestion in the network, or the packet drop was for some other reason. Because generally what happens is, suppose a node has sent suppose some packets that is destined for the suppose node at C, but suppose some packets are dropped in the network, so we assume that there is a congestion in the network. So is it possible to propose some new concept or technology through that we are able to detect whether it is a congestion or it is a packet drop for some other reason? We are not able to differentiate between these two. So can we able to differentiate with the help of this? Likewise, mobility modeling is another challenge. because in case of Adhoc Networks, most of this implementation of this network, whether it is MANET or VANET, it is very difficult for us to do the real time implementation or real world implementation of this, because it requires huge cost, and setup of this type of network requires a lot of hardware and assistance from the people from different branches. So most of us are doing the research only on the simulators. So what simulators, they are just represents this real world environment. For this we have mobility models available as, but these mobility models do not represent the actual scenario that is there in the real world. Like if we talk about the MANET, we have certain mobility models, like we have 2-day models, we have different models available. But if you talk about, and in this MANET we have mobility models, those represents the real world, somewhat actual. But if we move toward the other kind of Adhoc networks like VANET, then there we do not have much mobility models available as. So we can also propose a new mobility model for these simulators. Those are available so that they represents the real world environment exactly same onto the simulator, and we get the real world results on the simulator also. As I said, we can also provide the security mechanism available to this network, because whenever there is the communication is on the wired medium, the security, you want to just secure your ports and the medium, that is quite easier. But whenever the medium is wireless, the providing security is quite difficult. We need to provide the security onto the medium as well as onto the nodes as well as onto the interface, without further increasing the delay or reducing the throughput of the network. So for all these generally simulators, those researchers use are the NS2. We have GlomoSim, Qualnet, NetSim, Omnet, Omnet++. Lot of simulators are available. And out of this, NS2 is and GlomoSim are free of cost available to the users. Qualnet and NetSim, these are paid simulators available. This open source simulators and paid simulators both have their own advantages. Like in case of open source simulators, we get the opinion from the other researchers those are working on this area. We get the help from the blogs those are running on these areas. But in case of this simulators, those are paid simulator or licensed softwares, we need to always contact the proprietary company who is providing these simulators. Sometimes the patches are available with them, they provide us, but sometimes it is not available with them. They will not give us, or they request us for more money so that they provide us the updated version. Wireless sensor network is another area in which you can work upon. It is similar to the previous like Adhoc networks. So in this this wireless sensor network is generally used where it is very difficult nowadays. It is very difficult for us to reach at that particular location, like in the forest or underwater oceans. We just deploy the sensors from the aircraft, and those sensors will form the network amongst themselves. Underwater sensor network is the new area in which a lot of research is doing on nowadays. So these sensors are deployed from the high altitude, and these networks, when deployed, they form the network. These nodes or these sensors, they form the network amongst themselves and just collect the information from that particular location and pass on to the base station. And from base station, we can analyze that particular information. Generally, suppose few sensors are deployed at suppose one location, then most of them will provide us the same information. Like suppose I am going to collect the temperature of a particular forest. Suppose there is a fire, then most of this sensor will give us the information regarding the temperature. But in this case, we don't want the same information collected by these sensors and it is passed on to the base station, because it is unnecessary increasing our network load. We want to reduce it. So for this, we can propose some algorithm so that this network load can be reduced by applying some kind of aggregation and applying some kind of better information dissemination mechanism. And this initial deployment of this network using the sensor is also a major challenge. We can also find out the mechanism through which these nodes will form the topology. Like simple topologies we have studied earlier, like bus topology, ring topology. These topology will not work here because the sensors are deployed randomly. We want some kind of topology here in which this selection of the key node will be will change automatically after some time. And transmission media, as I said earlier, in this may be possible that some part of the network may be wired and some other part may be wireless. And in case of wireless also, in this wireless sensor network, the sensors or the nodes may be mobile also in this case, because suppose sensors are deployed in the suppose ocean. With the flow of ocean, some sensors may move from one location to another. We also want to have a fault tolerance in this kind of network. Like suppose if there are suppose 100 sensor or thousands of sensors in the network, and suppose some of the sensors suppose die due to some reason, so we want there should be some fault tolerance mechanism in the network. With the uh, suppose some of the sensors are suppose out of order, even that our network will be able to work. There should be some backup mechanism, or there should be some way out through that. Some other sensors, those are not yet died, they will form the new technology on their own. So we want some kind of algorithm or mechanism. And moreover, as I said, in the computer we have different operating system. Operating system is the basically the software which acts as the interface between the user and the hardware basically. So in case of hardware, in case of suppose laptop and computer, we have large hardware available with us, so big operating system is there. But in case of mobile phone, the device is comparatively small, so the normal operating system, those are valid for the computers, cannot be directly installed onto the mobile phones. Likewise, these operating system, those are available for the mobile phone or laptop or computer, they cannot be applied onto these sensor networks where these WSNs are used, because these sensors are very small. We cannot uh, use normal operating systems because they consume lot of power as well as lot of efficiencies used over there. But our sensors are very low in power, and computing capability is also very low. So we need tiny operating system for this. We also want our network to be scalable, because as soon as more sensors are, suppose one network has already been deployed, but suppose that is covering only an area of suppose 5 kilometers, so we can increase the range of these network by further deploying some more sensors, and some new sensor will form a topology or a network with the existing one also. In this way we can make our network more scalable, and for this we want to propose some algorithms or new technologies or some way out through which we can do this. We can also improve the power consumption or the energy efficiency, which is a big challenge in WSN. We can propose the new law for this, through which we can improve the energy consumption of the network. We can also provide the mechanism through which all these devices, these nodes or sensors or base stations, those are from far off from each other, they can synchronize amongst themselves, so that after some time, suppose after 10 minutes, one packet is sent from one sensor to the other one, so that they can synchronize among themselves. Their time, their clock will be synchronized, so that there is no need of further sending the start and stop messages again and again, because they are going to consume your network resources. Again, similar simulators, those are used in mobile ad hoc networks. They can be applied in WSN also. And cloud computing is another area in which people are working nowadays. Cloud computing, or you can say nowadays mobile cloud computing, people are working. So here we have two things, like one is the computing and another one is the cloud. Like earlier, if you go suppose 10-15 years back, if we want to suppose install the operating system, it is available in the form of CDs, and in that also we make the starting floppy. This is what I want to say, in that also we start with the help of floppy, so that it takes very less space on our CD. So we boot with the help of floppy, then after that we install with the help of the CDs. Then after that we have moved toward this pen drive, and nowadays everything is available on the cloud. All the softwares are available through the cloud. You can find out Windows 10, there is no CD available. They provide it with the help of laptops or computers, or if it is not working, you have to connect to the internet, through which they provide. Other software also like MATLABs and all these are Mac binded, and everything is available with the help of internet only. With everything is there on the cloud. Like suppose I am having a Gmail account, you are also having some similar kind of email account you have. So all these servers are maintained with the help of cloud. That is why these are available 24/7 to us. So in cloud, scheduling is a big challenge. Okay, how we can schedule these tasks onto the different machines, because for scheduling we have lot of resources available here. We have multiple computing, so computers or high computing power resources available to us. Tasks are coming from the users. We want to distribute it. How we can distribute it to different resources so that effectively we get the results and the equal load is distributed onto the different machines. Likewise, we do in this case of load balancing. We have distributed the load onto the different computing resources, how we are going to balance it, and we are getting the results through this, and how we are again clubbing back the result and providing it to the users. Then how we are allocating the resources to the users. Some resources, they require high computing power, and some users may require very low computing power. So depending upon their requirement, we allocate the resources to the user, and for efficient allocation of resources, we can propose some mechanisms or suppose hybrid approach that is well enough for the resource allocation and for the load balancing. And as I said earlier, these devices are basically highly mobile, and lot of people are using this, and they are also connected to the internet. So high security mechanism is required. Normal security mechanism that has been provided in the other kind of network cannot be straightaway applied here, because here the devices are, as I said, devices are very small. The mobile computing or cloud computing, these are limited to our smartphones only. So normal security mechanism like Norton antivirus early providing the security for our computer, it generally slows down the speed of our computer. So we need different kinds of antiviruses or mechanism through which we provide these security measures. Also, because we are using the network resources, we should provide the security so that some unauthorized person cannot access the resources. Those are not meant for it. Otherwise, the whole network will go down. And to provide all this, we also need the infrastructure, because like these companies, suppose Google is providing us the Gmail facility. For this, they have, suppose if I write any, just I'm trying to log in, I just provided my username and just password. Suppose just think of how many users are there across the whole globe, those who are using this Gmail. I think more than 100 crore users are there, those are using this Gmail. And within a fraction of second, I provide the username and it matches onto the large database, and then password is again matched, which is in the encrypted form. Then decryption is going on at the back end, then password matching to the whole database, and in a very fraction of second. So they are doing it with the help of very efficient algorithms. Those are they have implemented at the back end. So we can also work on that, how we can improve the data retrieval from the large database that is available in the cloud. How we are going to retrieve our information from this, and for that we need the large infrastructure. Data centers are available for these companies, and whenever these data centers are available, where we also need the cooling mechanism for this, because whenever high computing is there, lot of heat is also generated there. So we need a good cooling mechanism. For this, new mechanisms are provided. Like recently, I have come to know one of the company has installed their data center underwater to reduce this heating effect onto the network. And we also want the ubiquitous connectivity, how the users are all time connected with this network. Like we have the applications of smart homes, everything will be controlled by mobile phone. Like whenever I am going out, I can switch off the lights or TV or AC from my mobile phone only. Suppose it is the summer season, I am going to reach back at my home. I would like to switch on the AC 5-10 minutes before as I am going to reach at home. All this is possible with the help of nowadays with the help of ubiquitous connectivity. Here also we have some simulators. Those the researchers are using, like Cloud Sim, Workflow Sim, Cloud Analyst, through which we can simulate these environments. And these clouds are also available in the free and paid form. Through that we can use it. Another area of research is the artificial intelligence, in which we can provide some artificial intelligence to the machine, because normally the machines are not intelligent as the humans are. So for this, we can provide the knowledge management with the case-based reasoning in the main component, that is the knowledge base of this machine. We store the past decision that has been taken by the human or the machines in the previous cases, and we apply the same onto the coming one. Like Mycene is the example of this first expert system that was proposed in the field of medical image processing, sorry, medical imaging, where it stores the information from the into the knowledge base regarding the decisions taken by the doctor onto the various patients' history and decides according to that. In this area also a lot of algorithms are proposed, like ant colony optimization is proposed, and this algorithm is not limited to this computer science. This ant colony optimization is proposed in different fields also, like in electrical and in mechanical also. People have started applying this kind of algorithm in the research. Then planning and constraint satisfaction is also required in case of artificial intelligence. Machine learning is somewhat the new area, and that is the subcategory of artificial intelligence. We make our machine to learn the new things, and accordingly they take the decisions. Then semantic interoperability using the ontologies, XML, data handling, storage, indexing and query language is also a big challenge. As I said in the previous example, where Gmail is able to retrieve the information from the large database that it is handling and generate the result in a fraction of a second. So storage indexing or the PageRank algorithm that the Google is using, it is a big challenge. Online and exact algorithms also. For this, for artificial intelligence also, we have some simulators like neural network simulator, SimBrain, Stugrat neural network simulator, and some others are also available. We have distributed systems also. This cloud computing and distributed systems are somewhat nowadays, you can say, the club, because nowadays nothing is centralized, because centralized systems have one major drawback, that as soon as the your main computer goes down, everything will go down. That is why nowadays everything is distributed. But in case of this distributed system, normal algorithms, those are proposed from the normal databases, cannot be straight away applied to here, to the distributed systems, because in case of normal users, there is only one person who is firing the queries or suppose providing the decisions. But in case of this distributed system, we want some protocols like so that normally when the queries are fired from the remote locations, 1, 2, 3 locations, the decisions can be taken accordingly at any of the location, but considering the request from all over. We also want the parallel programming. Suppose one task is allocated to the distributed system, but first the major thing in that is the breaking of the problem into the sub problems, so that each problem can be simultaneously executed onto the remote locations, and after that providing the sub parameters or temporary result to these problems. Those are being executed at these locations, and further clubbing back the results and providing it to the users. In this, nowadays we are having object-oriented systems and component-based customization, cost estimation, and cost optimization is done. But the normal protocols like two-phase protocols cannot be directly applied to the distributed system. We have three-phase locking protocols and some other serializability management protocols available for the distributed system. For this, we have GridSim, SimGrid, and other grid lab simulators available. Another area is the image processing, in which researchers can do their research. It is also one of the key area in which people are doing the research. Like in the major focus nowadays is how we are able to suppose improve our agriculture, or suppose crop. We take the photographs from the satellites, then we are analyzing those pictures, and accordingly we take the decisions. Like suppose we have taken some photographs from the satellites and we have come to know that this area is dried up and the crop is not good enough, we can take the corrective actions beforehand. We can store the pictures of the last year, and accordingly we can also compare what has happened, how much the yield has grown up to till this time in this season as compared to this year. So we can compare this and take the corrective actions, and farmers can also take benefit of it. In this also we can compress the image, without reducing the quality of the image. For this, we can propose some mechanism. We can also enhance the image. So in certain cases, like suppose the image is taken from the very high altitude, we want to increase the quality of it. That is also a big challenge. We can do it in the form of static as well as the dynamic. We can also provide the digital watermarking, where we want to embed some information onto the picture and then pass it on to the user. That is also an authentic information which has been generated from the official sources. Then error resilient techniques for image transmission. If the image is transmitted from one user to the another one, how the quality and integrity of the image can be as it is there when it is received at the receiver. And the most common simulator used for this are the MATLAB and Scilab. Then data mining is another area in which people are doing their research. It is somewhat, you can say, the extension of your databases or distributed system, because whenever you want to retrieve the information from a very large data warehouse, it comes under the category of mining. Just we are mining the gold from the rock. It is somewhat like that. So developing a unifying theory for data mining, how we can scaling up for high dimension data and high speed data streams. Because generally in normal cases, when we were having the relational databases, we have generally two dimension X and Y. But nowadays we are going towards beyond that to the two dimensionality. We have different dimensions. Like in some cases, we want to analyze our sales pattern for the last 2 months on the basis of suppose customer details, on the suppose basis of how much sales has been done in the previous three months or 3 years. Different dimensions are there. So mining sequence data and time series data is a big challenge. Mining complex knowledge from complex database. So these are some of the challenges. Those are available in the field of data mining. How we can provide the data mining to biological and environment problems also. And society also plays a key role in this. Suppose I want to mine the information corresponding to the human, like suppose human diseases we want to analyze. So society also plays a key role, because we do not get the data sets from these agencies like the hospitals. They do not provide such information. So we should also have some kind of repositories available here through which we can get the data sets. And for this, the common tool available is the Veka. Nowadays people are also doing this research in the R and R Studio. We are also going to cover in this course also this. Big data analytics, as I said, normal databases have become the past. Now we are more focused on the big data, which basically correspond to the multiple V, where we have the large volume of data and velocity and different variety of data is there, and we want to retrieve the information. Like in case of Facebook, people are just uploading the images, people are also uploading the audio songs, people are also uploading the image in the different formats. Some are uploading in the JPG, some are in the PNG. But you can see the retrieval mechanism of the Facebook is very high. They are able to retrieve this data a very efficient way. So this data searching algorithms is the key role of this big data analytics, and how we are able to analyze this. If we are able to retrieve this information, further we want to analyze it, how the sales or the patterns are repeating after certain time interval. In query processing and analysis, then data aggregation and integration can also be applied in the big data. We can use Java, Python, RStudio, SPSS, MATLAB, and some other tools. MATLAB is however paid. RStudio is free of cost available. People have started moving towards it. Semantic Web is also another area in which you can work upon how information can be retrieved from the internet, and we can propose the case-based reasoning. And as I discussed earlier, the scalability and multilinguality is also a big challenge here. Like suppose one website is available or the database is available in one language, how the query that has been fired in a different language can be converted into the common language, and results are retrieved, and the results are generated back to the user in the language in which he has requested. So this is all what we have for this session.